All right, so in this section, we're looking at phase shifts or transformations of trig functions. So we're familiar with our basic trig function where we have our a and our b. Well, now this is going to be extended. Now we're going to have a transformation left and right on our x-axis. That's called the phase shift. And then later on, we'll add a vertical transformation or a vertical shift. So we remember that our amplitude is the absolute value of A, our period is 2 pi over B, and now I'm introducing phase shift, which I call negative C over B. Sometimes it's just written as C over B. It depends on how you look at this. If you include the negation with the C, it's negative C over B. So I include the negative with that. If you don't include it, then it would just be C over B. All right, I'm over explaining. Let's just do it the way it is. So let's take a look at this example. Just real quickly, if we were going to state the amplitude, the period, and the phase shift, I'm just going to call PS. We see our amplitude. Since there's nothing here, we can assume there's a 1, so it's the absolute value of 1, which is 1. Our period, which is 2 pi over B, my B here is 1, so it's just 2 pi. And my phase shift, I say, is equal to negative C over B. So I'm taking this in as my C with the sign. So it's the negation of negative pi over 2 over my B, which is 1, which will give me a phase shift of positive pi over 2, which means our entire graph, our sine curve, is going to move half a pi in the positive direction to the right, which makes sense because if you remember, transformations are counterintuitive when it comes to movement on the x-axis. Since this is a negation, it's actually going to go towards the positive end of the x-axis. So let's set up a graph here. Let's see what it looks like. So here I've graphed y equals sine x, our basic sine curve, with an amplitude of 1 and a b value of 1. And now I want to do my phase shift of 1/2 x, which means every one of these points is going to move half a pi. Did I say 1/2 x? 1/2 pi. So a point that once was at the origin here is now going to be located here. So let's write everything here. So we know pi and 2 pi, right? And negative 1 and positive 1. And the point that was at the origin is now going to be here at 1/2 pi. And the point that was once at 1/2 pi is now going to be at pi. Everything is getting shifted to the right 1/2 pi. And then we're going to have to extend this to 2.5 pi, right? 2.5 pi, which they're not going to write it like that. They're going to write it as 5/2 pi. And that'll be what our graph looks like. That would be the graph. Everything shifted 1/2 pi to the right. Right? This is pi over 2. So 1/2 pi, pi, 1.5 pi, 2 pi, 2.5 pi. And of course, this would continue in both directions, but that's what we would have. So one way to do it is physically like that, or visually, just shifting it over by the 1/2. Another way would be to find these points, right? Each one of these points here, we have 0, 0. We have pi over 2, comma 1. We have pi, comma 0 would be that point. We have 3/2 pi, comma -1, and 2 pi 0. We could also do it by just adding 1/2 pi to every x coordinate. Right? If I add half a pi here, I would have 0, 1/2 pi. If I add half a pi to my x coordinate, it would be 1.5. Oh, I'm sorry, to my x coordinate, it would be 1 pi. And then if I add it here, it would be 1.5 pi. And you see how it goes. We'll try another example, but that's basically it. So you can either do it physically, just moving it over, drawing lines, and moving the points. Or you could just add the phase shift to each of the x coordinates. Let's try another example. So let's look at this example. Y equals sine 2x minus half pi. I'll give you a second if you want to fill in what the amplitude, the period, the phase shift, and maybe the basic trig curve, basic sine curve, and we'll see what changes we have to make to it. I'll give you a second. So my amplitude, once again, looks like it's just going to be 1. The absolute value of 1 is 1. And my period is 2 pi over 2, so it's just pi. And my phase shift is negative c over b, so it's negative pi over 2 over 2, which would be equal to pi over 4 positive. Right? And if you're not getting that, negative and negative is obviously positive. If I have pi over 2, that's a complex fraction. I have a fraction in the fraction. I want to get rid of this denominator, so I multiply the top and the bottom by 2. So I get pi over 4. My basic sine curve, it's a positive sine curve. I know it looks like this. It has an amplitude of 1, -1, and it ends at pi. So that means this would be 1/2 pi, and this would be 1/4 pi. This is a very similar problem. What I'm going to do is I'm going to list out the points in this one instead of doing it just really all we're doing again. It's easy to do since we're moving at 1/4 pi, right? That's 1/4 pi. So now this point is going here. And this point is going here. Everything is moving this far to the right. So we could see right away what this is going to look like. Easy. But I want to list all these points that are here. 1, 2, 3, 4, 5. I'm going to list these 5 points, and then we'll add 1/4 to each one of the x coordinates and see what that looks like. Right, so this is currently our 5 points, 1, 2, 3, 4, 5. And what we want to do, since we have a phase shift of 1/4, we're going to add 1/4 to all the x values. Right, so now this will become 1/4, comma 0. 1/4 plus 1/4 is 2/4, which is 1/2, and 1. 1/4 plus 1/2 is 3/4. 1/4 plus 3/4 is 4/4. And 1/4 plus 4/4 is 5/4. So we could graph this. Right, if I know pi is here and 2 pi is, oops, let's get rid of that. I know that pi is here and half pi is here and 1/4 pi is here and 3/4, 1/4, 2/4, 3/4, 4/4. We're going to go out to 5/4 pi. And we're going to plot these points, 1/4, 0, 1/2 and 1, 3/4 and 0, and pi and -1, and 5/4 and 0. So it just, all that work and I wasn't even showing. So I plotted all these. I wish you saw it. But like I said, we just plotted all of these and then did it. So here, the same thing. I could have just moved this all over. And drawn it like that. But then if I asked you for a point, you would still be able to label all the points. So you're going to be asked for a phase shift and to label the points. You should be able to do that. Let's try another. So let's look at this example. Y equals 1/2 cosine 2x plus pi. Here I want you to distinguish your amplitude, your period, and your phase shift, and also your A, your B, and your C values. Because sometimes your A value is different than your amplitude, right? Because your amplitude is the absolute value of A. So I want to distinguish between the two. So my A, my B, and my C are obviously 1/2, 2, and pi. D would be over there, if it exists. We had it, or it does. Actually, I could say D is equal to 0, right? Plus 0. So my period in this case would be 2 pi over B. So it's going to be 2 pi over 2, which is just pi. My phase shift, negative CB. So it's negative pi over 2. So this is going to move half a pi to the left. So let's draw a basic curve. How's my graph look, right? So it's cosine positive, so it's my basic curve. My amplitude tells me how high and how low, so it's 1/2, negative 1/2. My period tells me where the end of one cycle is, so it ends at pi. So if it ends at pi, this would be half a pi, and half of that would be 1/4 pi. 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi. Now this is all shifting how far? My phase shift is negative 1/2, so everything has to move to the left 1/2 pi. So this point will now be here. And this point will be here. This point will be here. Right? So maybe I'm going to label all my points, and then I'm going to subtract half a pi and see what that looks like. So I've written down all the coordinates for each of these 1, 2, 3, 4, 5 points. And now what we have to do is we want to subtract 1/2 from all the x coordinates. Right? These are my x coordinates. I have to subtract 1/2 pi. So my new points are going to be negative 1/2 pi 1/2. Right? If I take half away from 1/4, I think we're going to have negative 1/4. Half away from a half is going to leave me 0. 3/4 minus 1/2. And pi minus 1/2 would be half pi. So those would be my new points. Let's take a look. Oops. Graph here. And my amplitude is 1/2 still. So we could start plotting points. Negative 1/2, 1/2. Negative 1/4 and 0. 0 and 1/2. 1/4 and 0. And 1/2 pi 1/2. So we could see how it shifted from where it once was over here, right? It has moved 1/2 pi to the left. All right, so this example looks very tricky. This looks like by far the hardest one we've seen. So why don't you take a minute or two and fill in what we know, our amp, period, phase shift, and our A, B, C, and D values. So our amplitude is the absolute value of 3, which is 3. Our period is 2 pi over B, which in this case, our B is 2 pi. So this one's interesting-ish. And then our phase shift is negative C over B, which would be negative 4 pi over 2 pi, which would just be negative 2. And our A, B, C, and D values are 3, 2 pi, 4 pi, and 2. So let's take a look at what a basic curve would look like. This is a cosine curve. It's positive. So let's take a look. Before any kind of transformation, we have an amplitude of 3, negative 3. My period is 1, so it ends at 1. So keep that in mind. That's why we use radians to graph, right? 2 pi, when we have a interval from 0 to 2 pi, that's really 6.28 approximately on our x-axis. Right? If we're going to think of it in the units, it would be about 6.28. So this is saying 1 unit. It's not bad. It's easy to do. It's actually an easier problem because of that. We don't have to deal with pi's. So now, Everything got shifted up 2 units. Does it make sense? Right? And again, you could do it visually, move it to the left and then move it up. That's what happened. It moved to the left 2 units and then moved up 2 units. Or you could subtract 2 from the x coordinate here and then add 2 to the y coordinate. We could have almost done it all in one step if we did it by coordinate. Right? By subtracting 2 from the x and adding 2 to the y, we could have gone right from here to the end. But this way we get to see the shift.